Okay, so today we're going to continue familiarizing ourselves with R language and RStudio. Okay, so in the previous class, I believe the last thing we discussed was variables, right? Yeah. So we basically tried something like that. So let me hide this, and I have it magnified so that you don't have to. You can see things bigger, right? So we did something like this. We said x equals 5, okay? And when you run it and then say, and this is capital X, right? So uppercase. Remember we discussed that R is case sensitive. That means that if I say lowercase x equals 5, and then I say please type uppercase x, it's not going to know what I'm talking about. All right, so when I do that, essentially what I'm doing is I'm allocating a space in memory where I'm recording one value. So in this case, it's going to be a numerical value 5, right? Or I can alternatively go ahead and say, quote unquote, hello world, right? Quote unquote, hello world. And same thing will happen, right? It will write, instead of 5, it will write hello world. And in R, in order to execute multiple lines of code, here's what I can do. So next one, I'm going to do true, right? True is not really a string, we discussed it, right? True and false, all capital letters, is a special type of data in R. It's called logical value or Boolean, right? So, and if I want to execute multiple lines in R, all I'm doing basically is I'm selecting all of these lines simultaneously, okay? And I can either hit the run button or hit Control Enter, same thing, and it will execute everything that I have highlighted. So at the end, in the bottom window, I will see the result of these two commands, right? Not too bad. Okay, so ladies and gentlemen, let's actually take it one step further, all right? What we just did is we worked with something that's called scalar variable, okay? Scalar. Whoops. Scalar means it's single value. So, for example, if I'm saying x equals 5, really what I'm doing is this. I'm telling R to allocate a piece of memory, okay, somewhere in the memory space, record number 5 inside of that, and my variable x is just a pointer that says, here is this a chunk of memory in the space that has value of 5, and I'm just pointing to that chunk, okay? So I can read from that chunk, write back into that, and it's all is done by using this reference, right? So x essentially is like an arrow that points to a location in memory, okay? And there I'm recording one single value. It can be either 5 or hello world or true, false, whatever it is. But the word scalar basically means that it's a single value, okay? Scalar means it's a single value. Okay? I can have a slightly different arrangement. So let's discuss something that's called a vector. What's a vector? You probably heard the word vector before, right? I'm willing to bet that you heard the word vector before. Here's what vector is, okay? Instead of writing inside this memory just one single value, I can have multiple values, but I'm going to call them using the same name, same variable, okay? So for example, I can go ahead and organize in the memory a chunk that is split really into 3 cells. You can think of that as a box with, like, you know, divisions inside of that, right? And I can put different values inside the box. For example, let's say I'm going to put numbers 5, 7, and 9, something like this, okay? And then I'm going to say x now points to a collection of values, really, okay? So a collection of values more than one, more than a single value, that's something that's called vector. You can think of that in terms of it's a one-dimensional storage, okay? Why do I say one-dimensional? Well, because it has, you can kind of, you know, how it's drawn right now. You can imagine it's a horizontal line, right, with values 1, 2, and 3. So x1, x2, and x3. And each of these cells has a different value. Well, let's go ahead and try that. Okay. Now, in R, just like in Python, I'm going to put that down. All right, you cannot just say x equals 1, x equals 5, 7, and 9. Here's what I'm going to need. Okay, and this is where we're going to use functions first. Okay, function, just like Excel function. You call the function in Excel to do something for you, right? Calculate the average, calculate the sum, or whatever, right? So here's what I'm going to do. I'm going to say x, I'm going to use lowercase x, okay? X equals, and then to create the vector, I'm going to say lowercase c. C is the name of the function, okay? And then inside the parentheses, after c, I'm going to say 5, 7, 9, okay? And if you run this line, so all I'm doing really is Control Enter, okay? So instead of clicking on the run button every time, all I'm doing is Control Enter. Then it runs the command, right? So apparently it did create a value for me, right? So now if I say print x for me, it'll show me all the values, 5, 7, and 9, right? So I'm using one name, but it's used to reference all 3 values, right? So more than a single value, a vector. If I want to look at only first one, here's what I'm going to do. I'm going to, after x, I'm going to put square brackets, okay? I'm going to say x, first element. Show me the x, first element of x. It'll tell me, it's 5. Make sense? What do you think it will tell me if I say x, third element? 9, right? Simple, easy as that, okay? Now, I told you that C is the function that basically creates a vector for me, right? And C stands for, I guess, combine. So it's a function that takes multiple values, combines them all together, and records that in one single variable, which is x, okay? So I'm going to leave a comment for myself here, okay? So I'm going to say create a vector variable named quote unquote x, okay? Remember what that means? If I put the pound sign and then some stuff after the pound sign, what do I use that for? Comments, right? So every time when I run the script, the R script, whatever I commented out, I put a pound sign and wrote some text after that, is going to be ignored by our interpreter, right? So it will read this line, it will say, hey, first symbol is pound sign, doesn't really mean anything, it's just a comment, so let's keep going. What's the next line, right? So, all right, so this is vectors, ladies and gents. And now let's discuss something even more exciting. And that's what we're going to be doing pretty much the rest of our semesters. Read the data sets and write the data sets into two-dimensional arrays. So you can think of that, let's go back to the drawing board, right? So we discussed vectors, scalars, right? Scalar is just a single value, not much, okay? Vector, I can record a whole bunch of different values. For example, let's say after the first exam, I have the exam grades for everybody, right? And if I want to record them and then analyze, calculate the mean, mode, median, standard deviation, I can use the vector, right? Because there are like 25 of us in this class, 25 grades, that's a vector, okay? So now if I want to take it into two-dimensional space, here's what I can do. I can go ahead and organize something like this. It's a two-dimensional data storage, which we're going to call, well, not we, it's what it's called in R and Python. It's called DataFrame. Okay? So DataFrame is a two-dimensional storage of data. And there it is. Okay? So here is how all of our data is going to be organized from now on. In columns, in each column, I'm going to have a separate variable. Okay? For example, let's say I have a two-dimensional data, and the first column will contain names, so it's going to be called name, and the second column will be grades. Okay? So let's start with simple example. Let's say I have name John, and John scored a 75 on the exam, and then I have Jane, and Jane scored an 83. All right? So this is a two-dimensional data set. So these are variables, okay? What we have in columns are going to be variables. So we have a variable, so these are variables. Okay? So I have a variable name, right? For each student I have a different name, and I have a variable grade. For each student I have a different grade. Now in rows, so this is my row number 1, this is my row number 2. Rows are going to be observations, individual students, right? John scored 75. That's information about one student, right? Jane scored 83. So in columns I have variables, in rows I have individual observations. Observations. Okay. All right. So let's go ahead and create something like this using R. Right. So let's go back. All right. And hold on. Let me go back for a second. Now, true or false? It looks like in order to create two-dimensional space, I need actually two vectors. First vector will have names, and the second vector will have grades. Okay? So let's try that actually. Okay? Now I promise you this is the first and the last time we're going to do that. Okay? It's an introduction to R. Okay? So we're going to be using data sets which are ready for us to cook, so to speak. So I believe it was lowercase. Yeah, it doesn't matter. We're just experimenting, right? That's it, nothing more. So I'm going to create a vector with names. Now you tell me. So I'm going to call, by the way, the variables, I can give names whatever I want, right? So far I was using x. X is kind of faceless thing, right? X, what is it? So let's use meaningful names, okay? So I want to have a vector with names of students, right? So I'm going to call my variable names. Yeah, another thing that I wanted to show you about R, I can just simply use equal sign, right? Or alternatively, and this is weird stuff quite honestly, you can go ahead and say less than dash, okay, together, no space between them, right? That's also a symbol, this is an equal operator. So you can either say equal, or you can do that, arrow pointing towards the variable, okay? All right, so now you know that the function C, which stands for what, by the way? Combine, right? Function C can create variable of the vector type for you. So I want to create a vector of two names, right? John and Jane. So tell me, what should I type? You tell me and I do it. Create a vector with two names. C. Then first one is quote unquote, right? It's a string, right? I cannot just say John without any quotations. It's not gonna like it, right? So I'm gonna say John, and after that, also in quotations, I'm gonna say Jane. Okay? So run this line. At the end, you will see blue. That means it worked, right? So we did create a vector with names. Well, now I want to create vector with grades. Okay, grades, arrow, and again, same thing, right? C. And grades are numbers. Is that correct? Do I need quotations? No. So what was that? 75 and 83, something like that? 75, 83. Okay. So I have created two vectors. And now I have to put them side by side to create a two-dimensional storage. How is two-dimensional storage called? DataFrame, right? So I'm going to create a DataFrame. So let's go. I'm going to create, how should I call it? I don't know, quite honestly. Students, excellent idea, students, okay? And I'm going to say, students will be a new variable for me, right? And I'm going to start typing data. Ooh, look at that. This is another cool feature of RStudio. You will not see that in R. That is only in RStudio, okay? Microsoft, I believe, originally introduced things like that in the programming world, and this is something that's called dynamic help or Intellisense, okay? What does that mean? As you start typing, and Excel has the same option, right? As you start typing equals average, once you like A, V, A, it already gives you a bunch of options, right? Same thing here, okay? as you start typing, if RStudio sees, this is something that I recognize I have a bunch of options, right? That starts with exactly the same combination of characters. It will show it for you, okay? So I want to create data frame. I'm going to select data frame. And all I need to do really is feed the data frame my two vectors, okay? I'm going to say, create the data frame for me, please, from the variable names, comma, and grades, okay? And when I run it, hopefully, it'll show the blue stuff for me, right? If you see the red, that means you messed up somewhere, okay? Everybody's blue? No pun intended. All right, so now let's look at it, okay? Now I'm going to say, show me students data frame, please, Mr. RStudio. So I'm going to just hit Control Enter, right? Just type students variable. Please show me what's inside. And there it is, okay? Pretty much exactly what I had here on my, where is it? Yeah, right here, okay? On my whiteboard. I have first column that contains names and second column that contains grades, right there, okay? How are we doing so far? You with me? No questions? I typed students, create data frame out of vectors names and grades, and then show me the students variable, okay? Now here is something useful. Yes, ma'am? Over here? You cannot. Hold on. Okay. Good question was asked, and let me bring it up. All right? Let's discuss that. Let's kind of step back, okay? This is my code script editor window, right? I can modify things in this window. At the bottom is my sort of output window, right? This is the result of execution, okay? So I want to edit my scripts right here. And when I run them, the result should be displayed at the bottom, right? So how do you create a new script? That's something that you will do at the exam and or quiz, right? On the top, there is a plus button. And if you hit that, it's going to say RScript. When I click RScript, it will create a fresh, clean script editing window for me, okay? So don't write all your code right here. This is an execution window, right? I mean, you can type it here, but you will not be able to go back and change it, all right? So here, on the other hand, on the top, you will be able to change your code and run it again and change it and run it again and do whatever you need to do, okay? All right, how are we doing so far? Good?
Do you have to save it every time? Do you recommend saving what you wrote?
Yeah, so I didn't save the script yet. Yeah, since this question came up, let's discuss that as well, okay? What happens? You don't want to lose your work, right? Essentially. So here's what you need to do. If you go to the file menu, just like in Excel, Word, or any other program that you know, then there is an option Save As, okay? So I'm going to save it as, and if I want to put, for example, it on the desktop, or here's what I would actually recommend, okay? All the code that we're going to be writing and all the data that we're going to be using, we will store, just for simplicity's sake, in the folder data on the disk C, okay? You will see in a moment why is that useful, all right? But, so I'm going to go to the drive C, data, and save as type, well, all files. So this one I can save as example.r, okay? So all scripts that we're going to be doing, they will have to end with an extension R, right? So all the files that R and RStudio are using, they should be ending with R. So, and then if I save it, then it goes to this folder, drive C, folder data, and it's there, okay? So yes, General rule of thumb is, as you go, keep saving this stuff, because if something happens, you don't want to lose your work, right? Okay, one more thing that I wanted to show you guys is this. Sometimes I don't know what the function does or how it works. In this case, I can call for, well, there is always Google, right? So there is no shame in using Google, especially when it comes to programming. Take it from somebody who did my fair share of programming. If you're struggling with something, somebody already struggled with that, okay? And they posted this question online, and somebody answered that question, more than likely, okay? So every person who does the coding, doesn't matter in what language, R or Python or JavaScript, they're using Google, no question about it, okay? But there are simple cases, like for example, let's say I don't know how the function C works, okay? What does the function C do? Combine, right? It combines values, creates vectors, right? So I can do it in a couple of ways. I can go ahead and say help, and then parentheses, and then type the name of the function that I'm looking for, right? So in this case, I'm looking for the function called C, right? So I'm asking R to show me the help, how this function works. And when I hit enter, or control enter, right? Then in another window, right there, on the right side at the bottom, it will show me pretty much what the function does, right? Description, the usage, so how it's being used, everything that I can send to the function, okay? And then if you scroll at the bottom, there will be a few examples of how this function is being used, okay? So alternatively, instead of saying help C, I can go ahead and say question mark. It's the same thing essentially. Question mark C, all right? And if I run this line, control enter, it will do the same exact thing. It will show me help for the function C, okay? So two ways how you can call up for help in R/RStudio, okay? All right, now, ladies and gentlemen, this part is important. Let's discuss how most typically data are stored for further analysis, okay? I mean, what we did right now is we typed list of names and list of grades, right? Do you think data analysts who want to slice and dice their data sets, they do this? They go to the computer and start typing their data sets? No. They read data sets that were given to them, pretty much, right? The most frequently encountered way, the most frequently used way how the data is stored and then analyzed is something that's called CSV file. How many of you heard about CSV files before? 2? Mark? Okay, 3 people. Okay, let's discuss CSV files, all right? Because this is by far the most popular way to store information, okay? CSV files. CSV file, okay? CSV stands for comma separated value, or values, okay, rather, values, right? What does that mean? That means that you can create, in fact, that's what we're going to do. You can create your own data file using, I don't know, Microsoft Word, or Excel, or simply Notepad, okay? And this is how the file is going to look like. Remember this example that we just discussed, right? Essentially, this is how I can organize my file, line by line. This is going to be line 1, line 2, and line 3. Now, line 1 is not going to be the data, agree? Names and grades going to be the titles, are going to be titles of my variables, right? The actual data, so this is line 1, line 2, line 3. The actual data will start in line 2. And then each next line is going to be just another student, another observation, right? So, comma separated is exactly how it sounds. The values which are separated by commas, okay? So, let's create, for the first time apparently in most of your old lives, okay, and for the last time I hope, our own file, which is going to be a CSV file. So we're going to create that exact data that we see right here and save it as the file, okay? So, let's go back and go ahead and find on your machine Notepad, simple Notepad, okay? Notepad editor. So click on the start button, start typing Notepad, and when it shows up, click on that, and this is probably what you will see, right? Notepad. So I'm going to create the same exact data file as what I already did, sort of programmatically, right? I created two vectors, combined them together, and got my data frame, right? I'm going to create my data file and then read it into the RStudio, R. Okay, so first line should be titles of my variables, right? So first one is names, comma, because it's a comma separated values file, right? And then the next one is grades, right? Hit enter, that's my line 1. Quite literally, line 1. So first one was John. I'm not going to do any quote unquote because R, when I read this file in, R will figure it out, okay? It will see that, hey, first one has alphanumeric characters. So it's a string probably, right? It's definitely not a number. John, what was John's grade? No space. 75, right? Don't hit space, by the way, okay? Don't do it because space is yet another character, right? It can mess things up a little bit. Next one was Jane, and Jane, comma, no space, was 83, right? And then go ahead and hit another line, but don't type anything, okay? So after you typed up the second line, just hit enter without typing anything, okay? So this is my data file. Do you see why it's called comma separated values? Because I have values separated by commas, right? And each line is literally a new line in my data file, a new observation. Okay, so I'm going to go to the file, save as. You do the same thing, okay? Remember how I told you that we're going to put everything into the folder C, drive C folder data, right? Let's do exactly that. So go to your drive C. You should have on your machines folder called data. If you don't, if you're using your machines, go ahead and create under the drive C folder called data. Okay? Okay? Alright, so I'm going to put it in the folder data, and I'm going to choose when I save my file all files. Alright? And here I'm going to type students, right? That's what we call that, right? Students dot CSV. Dot CSV is important, okay? So I'm going to save my data in the comma separated values format. How are we doing? Okay? All right. So I'm going to save it. And now I have the file with my data physically on my machine, right? Sitting in my drive C folder data. Now here's what I'm going to do. Remember our discussion 5 minutes ago that data analysts don't really do that. They don't type their own data before analyzing it, right? They bring the data inside the memory. They bring the data into R, right? So I'm going to erase all of that. And now let's do reading of the file, okay? So now I'm going to take the file, which is physically located on my machine, right? And I'm going to read it into the memory so that I can slice and dice, do whatever I want with it, okay? So here's how it's done. I'm going to put comment first, right? Read a CSV file from C drive. Okay. Well, first and foremost, probably, when I say read, I should store it somewhere, right? So therefore, I should have some sort of the memory allocated, and I should have this memory named, right? Just like I was typing x equals 5, right? Chunk of memory named x. Same thing here. I'm bringing the data into the memory. I have to call it somehow, right? So students, right? Students, just like what we had before. And I'm going to say into the variable students, please record the result of reading the CSV file. And here's what I'm going to do. I'm going to start typing read. And as I start typing, it tells me, I have some things, some commands that I recognize that start with the word read. One of them is read CSV. Do you think it's the one that we should use? Yeah, probably. Okay. So I'm going to pick read CSV. And the next thing that I have to do is specify for my command precisely where the file is located. Okay, so let's try stupid thing. Okay, what I'm about to do is stupid. Don't repeat that. on the exam and or quiz. I'm going to say, well, the file, I saved the file, how did I call it? Students.csv. Let me go ahead and say students.csv. Should make sense, right? I know that I saved it as students.csv. Makes sense for me. So when I run it, it'll say, cannot find the file, cannot open students.csv, no such file or directory. What do you mean no such file? I just saved it, it's there. Drive C, folder data, file CSV. Oh, you know what? I forgot to tell where it's located, right? Where is it located? On the drive C in the folder data, right? I know that, but computer does not. So therefore, the fully specified file name is not just the name dot extension. It's also the path to the file. So I'm going to say C column slash data slash students.csv, okay? So I'm going to fully specify the location of the file. That is on drive C inside the folder data, and it's called students.csv, okay? Make sense? So this is one of the most frequent errors that I see like on first quiz, okay? You will get used to it. As we analyze more and more data, it will become natural for you, okay? But a couple of boo-boos can happen on the way. And this basically me explaining to you that, hey, computers, that's what I'm telling everybody, okay? Computers are stupid. They can do only 4 things really quickly and really nicely. Add, subtract, divide, multiply. This is it, okay? So they don't have cognitive capabilities, all right? They don't know, this machine that I'm working with doesn't know that my file, where my file is located. I have to tell computer where the file is, okay? So now that I have the full path, when I run, there is no red, right? So apparently I did read the data from the file, okay? And now I can go ahead and, well, show the data. So please show me what's inside the variable students. And you understand, right? That this line essentially what it does is it finds the file, opens the file, reads everything from the file, and puts that into the variable called students, right? That's what it does. So now if I want to show what's inside the variable students, I just say students, and there it is, okay? Again, columns are variables, rows are individual observations, individual students in our specific case. Make sense? Any questions? Concerns, complaints, sarcastic comments? This is fun, yeah, I'm telling you, this is fun. This is the greatest course, honestly, okay? Out of all courses that I'm teaching or ever taught in Luther School of Business, I probably like this one the most, quite honestly. All right, so this is how the data are being analyzed pretty much all the time, okay? If I'm an analyst working for a company and my boss tells me, hey, analyze sales or analyze, you know, employees' records, okay? How do I do it? First thing to do is to get the file with data, right? And typically, more frequently than not, more often than not, this is the .csv file. Could be pulled out of anywhere. Could be pulled out of the database, for example, or somebody sends it to me. I don't know how I got the file, but typically, when I get the file, it can be large, okay? I put it on my machine, data.csv or whatever it's called, but .csv at the end. And then the first thing that I do is this. I'm going to read that into the memory of the machine and then start slicing and dicing, okay? Start doing charts and different models that we're going to be doing starting next week, etc., okay? All right, so we still have about, what, 5-7 minutes or so, right? Let's see, yep, 8 minutes. Let's get started with analyzing the data that has no practical value, but it's kind of, it can illustrate some good concepts for us, okay? Titanic, you all heard about this magnificent ship, right? That met with an iceberg, and that was the end of it, pretty much, okay? So there is a file. I posted that actually on Scholar, so go to Scholar, all right? And go to our folder on Scholar, and on the left side, ooh, hidden, okay. I created a new folder where I'm going to post pretty much all the files that we will look at during this semester, data files. So open up the files, okay? And there is one single file right there called titanic.csv. All right, let's download that. Now when you download something, at least on the Windows machine, it goes to the folder downloads, right? I'm going to take it from the folders download and move it into the what folder? Data, right? So everything that we'll do this semester will store in the folder data on the drive C. Okay, so I'm going to go to the folder downloads. Here's my Titanic. And I'm going to copy that, right? Or cut, whatever you want to do. Cut, all right? And then go to folder data on drive C. All right? And then just right click anywhere and say paste. Okay? Well, apparently I already had one Titanic, so it pasted with a different name. Yes, ma'am?
Is it saved as a comma delimited file, or is it saved as an Excel file?
It will save, yeah, about that, right? So, do you see the .csv on the file? But you also see probably the icon that says Excel, right?
No, it's when I on my device would like to save as type and CSV is the type.
Yeah, CSV is the type, right? So save it as CSV file, okay? Now, a lot of you, if you're working on Windows machine, then you will see CSV file with icon, which basically spells Excel, right, on it. That's because, you know, in Windows, with each file type, it identifies the default application that should be used to open these data files, okay? So CSV files, standardly on Windows machine, are opened using Excel, okay? So, for example, right now, you can see that in my download folder, I have Titanic file, right? If I double click on the file, guess what? It will open in Excel, right? So it's not an Excel file, really, but Excel will be used to open it. And there it is, okay? So it has 4 columns and God only knows how many entries, right? So default application on my Windows machine to open CSV files is Excel. And that's pretty much how it is probably on Apple's as well, on Macintosh machines, okay? So I don't really need to look at the file right now, so I'm going to close that. But the file is on my machine, right? So let's go back to RStudio, okay? And I'm going to erase all of that stuff. Now let's read the file from the data. Let's read other way around. Let's read the data from the file, right? So I'm going to call my data. Do you remember I told you that I should name my variables in a meaningful way, right? How do you think I should call my data variable? Titanic. Let's call it Titanic. Titanic. All right, and then I'm going to say in the variable Titanic, I will record. How do I read the data from the file? Remind me. I should say read CSV file, right? And then after that, yeah, I'm going to have to specify precise full location of the file, right? I'm going to have to say disk C, in the disk C folder data, in the folder data file called Titanic and .csv. If I leave it out, let's see what happens, just out of curiosity. Read Titanic for me, please, R. So when I run this line, it says Titanic. Don't know what you mean, my dear friend, okay? So I have to be precise, okay? So I have to say .csv. And then it works. If I run this line, I can see that there is a blue line, executed line in my output window, right? How are we doing? Everybody's with me? Okay. Well, in the time remaining, I guess we can do one last thing, all right? Typically, so let me actually leave out the comment, right? So I'm going to say # read titanic.csv data file, okay? All right. Typically, right? When I read the file into my variable, when I read the data from the file, I want to see what's inside, but I don't want to see everything. Well, I can technical, right? So let's look at everything. I'm going to say Titanic, please show me what's inside, right? When I hit enter, here's my output, okay? It shows me starting from string from line number 1, class first, adult for the age, male for the sex, and survived, yes. all right? And I have a bunch of them, of these records, right? But it stops at 250 and it says, well, this is it, okay? There are so many of them, I'm showing you 250 and I'm bailing out, and there are 1951 more rows which I chose not to show. Sorry, just too much, okay? All right, fine. But what I want to do is kind of, I don't need to know all of these data, right? There are like a bunch of observations. I don't need to see every single one of them. But can you give me like a synopsis? What's inside my file, just generally speaking? So here's how I can do it. So let me go ahead and put comment, and here I'm going to say show structure of data. Okay? And that is done by using the function str. Can you guess what str stands for? Structure. Okay? So I'm going to say str of my Titanic data, lowercase, right? Can you show me, please, the structure of my data set? And when I run this line, Control Enter, right? Then let's take a look. It tells me, does not show me all 2,000 something observations. It tells me, well, there are 2,201 observation in this file, correct? That means this is the data about 2,201 passenger of the Titanic, right? It says there are 4 variables. Why do you think it says 4 variables? There are 4 columns, right? Remember our discussion today? A column is a variable, right? And what are the variables? First of all, it's a class. Uppercase C, right? That's going to be important. And it says that for the class, there are 4 levels. Okay, that means that there are 4 different options. Now it shows only 2. Crew, first class, and what it doesn't show is second class and the third class. So there are 4 options for the people on Titanic, okay? It could be first class, second, third, or part of the crew. Then there is age, and age typically is a number, right? But in this file, they replaced the number with just 2 options, okay? It can be either adult or a child. So I'm guessing is they had some sort of the cutoff, like when the child stops being child and becomes adult. What do you think? What age? 13, okay, 13. A little early, probably, but let's say 18. Okay, so anybody 18 or less are classified as a child. Anybody is above 18, adults. Okay, probably that's how it's done. Sex, self-explanatory, male, female, right? And survived. For each passenger, we know if they survived the crash or they drowned, right, in the crash. So for each passenger, we know yes or no. Did they survive yes or did they survive no? Okay. So that basically gives me the brief summary of what's inside my file without looking into the specifics, right? It doesn't show me all 2,200 numbers, or lines rather, okay? It just tells me the brief synopsis of how my file looks like. Okay, so we're done for today. Next class, we're going to start slicing and dicing this data using RStudio, okay?